Part 2 of the universe, our Milky Way galaxy. So let's start. Here's overview. Discovery of galaxy, structure of galaxy, the spiral arms and star formation, nucleus of the galaxy, origin and history of the Milky Way galaxy. What is a galaxy? A galaxy is a system of millions or billions of stars together with gas and dust held together by gravitational attraction. Discovery of the galaxy. Great star system. The ancient Greeks named that the band galaxies who close the Milky Circle. The Romans changed the name to Via Lactea, meaning Milky Road or Milky Way. Galileo's telescope revealed that the glowing Milky Way is made up of stars, and later astronomers realized that the Sun must be located in a great wheel-shaped cloud of the stars, which they called the star system. In 1750, Thomas Wright used the term universe because, so far as was known at the time, the Milky Way star system was the entire universe. In the 18th century, astronomers Sir William Herschel and Caroline Herschel, Sir William's sister, set out to map the three-dimensional distribution of stars in the Milky Way. The Sun is located near the center of this grindstone model universe. Seen edge on Herschel's model of the star system was a very irregular disk. Here is the Sun. Milestones used to grind floor when thick disks of reminded astronomers of the disk shape of the star system. Variable stars and distance estimates. The variable stars Leavitt-Shaw Cepheids are named after the first such star discovered, D. Cepheid. Many Cepheid variables are known today. They have pulsation periods from 1 to 60 days and lie in a region of the HR diagram known as the instability strip. Cepheids are clearly giant and supergiant stars. A related kind of variable, RR Lyrae stars, are named after the variable star RR in the constellation Lyra. They have a pulsation period of about half a day and lie at the low luminosity end of the instability strip. Cepheid variable star in galaxy M100. April 23 it look like this. May 4 it look like this. May 9 it look like this. May 16 it look like this. May 20 it look like this. And May 31 it look like this. Pretty amazing, right? And it is changing. Size of the Milky Way galaxy. The Milky Way is only 100,000 light years in diameter. Structure of galaxy. Before starting with the slides of structure of galaxy, let's look over this photo. Thick disk, which is in here, bulge stars, globular clusters, that yellow dots, halo the stars, and thin disk, the stars are gas. What are the components of a galaxy? Disk component. It contains most of the galaxy's star and nearly all of its gas and dust. Because the disk is home to the giant molecular clouds within which stars form, nearly all the star formation in a galaxy takes place in the disk. Halo, a spherical cloud of stars and star clusters that contains almost no gas and dust. Because the halo contains no dense gas clouds, it cannot make new stars. A flattened cloud of billions of stars about 6 kpc in diameter. So what is kpc? I will tell you that. So a full form of a kpc is a kiloparsec, which means kilometers per second, and if we convert that into meters, it will be 3.086 E plus 19. Astronomers often refer to the halo and the central bulge together as the spherical component of the galaxy. What is the mass of the galaxy? Current observations indicate that the Sun orbits the center of our galaxy about 240 km per second, moving in the direction of Cygnus. The evidence suggests the Sun's orbit is nearly circular. So, given the current best estimate for the distance to the center of our galaxy, 8.2 kiloparsec, you can find the circumference of the Sun's orbit by multiplying by 2p. The spiral arms and star formation. Tracing the spiral arms. Those spiral segments have been named for the prominent constellations through which they pass. Astronomers are now using infrared and radio telescopes to penetrate the interstellar dust, locate more distant OB associations, and trace the spiral arms even further. Objects used to map spiral arms are called spiral tracers. Radio maps of spiral arms. Radio astronomers use the strong spectral line emission from carbon monoxide (CO) to map the location of giant molecular clouds in the plane of the galaxy. Spiral density wave theory. In the spiral density wave theory, spiral arms are dynamically stable regions of compression that move slowly around the galaxy, just as the truck moves slowly down the highway. Gas clouds moving at orbital velocity around the galaxy overtake the slow moving arms from the behind and slam into the gas already in the arms. The nucleus of the galaxy. Observations of the galactic nucleus. Observation at radio and infrared wavelengths reveal complex structures near SGRA caused by magnetic fields and by rapid star formation. Supernova remnants show that massive stars have formed there recently and exploded at their end of their lives. The center is crowded. Tremendous numbers of stars hit the dust, which emits strong infrared radiation. Finally, there is evidence that SGRA is a supermassive black hole into which gas is flowing. Observations of the motions of stars orbiting the central object indicate its mass is at least 4 million m. Supermassive black hole. Origin and history of the Milky Way galaxy. The element building process. The first stars that formed early in the universe history therefore had to be nearly pure hydrogen and helium. All of the other chemical elements have been produced by nucleosynthesis. I repeat again, nucleosynthesis. Nucleosynthesis. The process in stars that fuses hydrogen and helium to make the heavier atom. Stellar populations. They form and evolve in similar ways, but they differ, especially in their abundances of metals. Populations. Population 1. Stars are metal rich, containing 2 to 3% metals, whereas population 2 stars are metal poor, typically containing less than 0.1% metals. The age of the Milky Way galaxy. The oldest open clusters are 9 to 10 billion years old. These ages come from the turn of points in the HR diagrams, but finding the age of an old cluster is difficult because old clusters change so slowly. Studies of the oldest globular clusters suggest that the halo of our galaxy is at least 13 billion years. Formation of galaxy. The monolithic collapse hypothesis top down says that the galaxy formed from a single large cloud of turbulent gas over 13 billion years ago. That cloud contracted to form our galaxy. As gravity pulled the gas inward, the cloud began to fragment into smaller clouds and because the gas was turbulent, the smaller clouds had random velocities. The children of the Milky Way. In a nutshell, the sun with the earth in its clutch is ripping along at about 240 kilometers per second. That's 500 that's 540,000 miles per hour. As it orbits the center of the Milky Way galaxy. We live on a widely moving ball of rock in a large galaxy that humanity calls home, but the Milky Way is more than just our home. Perhaps parent galaxy would be a better name except for hydrogen atoms, which have survived unchanged since the universe began, and you and Earth are made of metals, atoms heavier than helium. There is no helium in your body, but there is plenty of carbon, nitrogen, and oxygen. There is calcium in your bones and iron in your blood. All of those atoms and more were cooked up inside or in their supernova depths. Stars are born when clouds of gas orbiting the center of the galaxy collide with the gas in spiral arms and are compressed. That process has given birth to generations of stars, and each generation has produced elements heavier than helium and spread them back into the interstellar medium. The abundance of metals has grown slowly in the galaxy. Thank you guys. Hope you enjoyed this video, and please subscribe my channel and like this video. And I wish you good health. Bye bye.